Hello students, welcome to the class. So which is a continuous section of power series representation of analytic function. Okay, we start with the proposition. Proposition says that let f is a mapping from G to C be analytic. Suppose we have a region G and the mapping f from G to complex plane C is an analytic function. Okay, analytic function, that means it is continuously differentiable function, right? And suppose that G has the property that if you consider a point A in G, then there is some radius R, is there some neighborhood, okay, some neighborhood centered at A with the radius R is its closure, actually a closed neighborhood, its closure is completely contained in G. Okay, for any A in G, G has the property that any radius r greater than some other radius r greater than 0 is that a closed ball centered at A with radius r is completely contained in G. Okay, now we consider a closed curve gamma of t equal to A plus r e raised to it, where r is a radius. Okay, gamma of t equal to A plus r e raised to it. So what is this gamma? A plus r e raised to it is 0 less r equal to t less r equal to 2 pi, which is nothing but, suppose A is here, then you consider a circle. You consider a circle, okay, centered at A and radius r. This circle is denoted by gamma. Okay, this curve is gamma. Then we need to prove that fz can be rewritten as 1 by 2 pi I integral over gamma fw divided by w minus z dw for the neighborhood mod z minus a less than r. That means in this region, okay, in this region we need to find out, we can find out fz as 1 by 2 pi I equal 2 pi and integral over gamma fw divided by w minus z d gamma. Okay, so I can say that which is some lighter version of Cauchy's integral formula. നോക്കൂ, നിങ്ങൾക്ക് ഈ ഒരു റെപ്രസെൻറ്റേഷൻ ഓർമ്മയുണ്ടാവുമായിരിക്കും. ഇതൊരു Cauchy's integral ഫോർമുലയുടെ അല്ലെങ്കിൽ Cauchy's തിയറത്തിൻ്റെയൊക്കെ ഒരു ഫോർമാറ്റിലാണ് ഇത് കിടക്കുന്നത്. പക്ഷെ ഇവിടെ എക്സ്ട്രാ ഒരു പ്രോപ്പർട്ടി പറഞ്ഞിരിക്കുന്നത് എഫ് അനലിറ്റിക് ആണെന്നും ക്ലോഷർ ഓഫ് എ neighborhood is contained in G. ഈ പ്രത്യേകതയുള്ള ജിക്കകത്ത് if you consider any simple closed curve centered at the point A, then in that region fz can be written 1 by 2 pi integral over gamma fw divided by w minus z dw. Okay, let's see how we'll prove this. Okay, this theorem is also proved by using previous theorem we discussed in the previous video. Okay, that means suppose we have a function psi which is continuous, then you can define a function g which is the integral of that psi, then g will be differentiable and g dash of t will be equal to integral partial derivative of psi with respect to t with the variable guess. Okay, so for that I define a set, consider g1 equal to, I define a set g1. G1 is a set consists of set of all elements of the form 1 by r into z minus a, where z is an element in G. അപ്പോൾ G എന്ന് പറയുന്ന സെറ്റ് ഉപയോഗിച്ച് ഞാൻ G1 എന്ന് പറയുന്ന ഒരു സെറ്റ് ഡിഫൈൻ ചെയ്തിട്ടുണ്ട്, which is 1 by r. This r is a radius of the open ball centered at A. Okay, z minus a, z in G. Okay, then define G of z is equal to f of a plus r z. Then you define G of z is equal to f of a plus r z. Now for the convenience we are assuming a equal to 0 and r equal to 1. That means we are considering the point 0 with radius 1, unit radius. So that our assumption, by assumption we have B closure of AR is contained in G for any A and any R. So since A equal to 0 and R equal to 1, we can assume that B closure of 0, 1 is completely contained in G. Okay, right. Now we fix a point Z such that mod Z is less than 1. So instead of proving mod z minus a less than r, actually we want to prove that when mod z minus a is less than r, fz can be written like this. So for that we will prove if mod z is less than r, that means a equal to 0 and radius equal to 1. So for mod z less than 1, we will prove that fz can be rewritten as 1 by 2 pi into integral over gamma fw, this integral format. Okay, we have to prove that fz can be written 1 by 2 pi I, okay, integral over gamma fw divided by w minus z dw. So this is we need to prove. So that is we want to prove that fz can be written as 1 by 2 pi I into, what is integral over gamma fz dz? So integral over gamma fz dz is integral over a to b, integral from the range of gamma, that is the trace of the gamma, a to b, f of gamma of t, gamma dash of t dt. Yes, we know the line integral format. Integral over gamma fz dz is equal to integral some a to b, that is the range of gamma, and f of z of t or f of gamma of t, gamma dash of t dt, right? So we know this result. So by using this idea, this integral can be written integral from the range of gamma. Here range of gamma is 0 to 2 pi. So this is 0 to 2 pi. Okay, f of gamma of t, gamma dash of t dt divided by here gamma w, instead of w I have to write gamma of t, right? Gamma of t minus z. Okay, so that is 1 by 2 pi I into integral 0 to 2 pi. What is f of gamma of t? And we have gamma of t equal to a plus r e raised to it. Okay, and we have chosen that a equal to 0 and r equal to 1. Therefore gamma of t will be e raised to it itself. Okay, then what is gamma dash of t? I e raised to it. Okay, so this will become f of gamma of t will become we have f of z is equal to which I can write f of e raised to it, because gamma of t equal to e raised to it into gamma dash of t, that is I e raised to it, okay, divided by, here I have to write e raised to it minus z. Okay, e raised to it minus z dt. Now I change the variables as 1 by 2 pi integral 0 to 2 pi. This can also written f of e raised to is, and this I will be cancelled. Okay, so this will be 2 pi itself. F of e raised to is, e raised to is minus z ds. Okay, I represent this integral as in the variable of s. So we get fz is equal to this, that is 2 pi I, this 2 pi into fz can be written integral 0 to 2 pi, okay, e raised to is into f of e raised to is divided by e raised to is minus z ds. Okay, now this 2 pi can be written, we have in the left side 2 pi into fz എന്നായിരുന്നു left side ൽ ഉണ്ടായിരുന്നത്. ഈ 2 pi നെ ഞാൻ എങ്ങനെ എഴുതുന്നു? fz into 2 pi can be written integral 0 to 2 pi ds, which is equal to integral 0 to 2 pi e raised to is f of e raised to is divided by e raised to is minus z ds. Okay, so നോക്കൂ, ഈ ഇൻ്റഗ്രലിൽ വേരിയബിൾ ഈസ് എസ് അല്ലേ. സിൻസ് ദ വേരിയബിൾ ഈസ് എസ്, എഫ് സെഡ് ക്യാൻ ബി റൈറ്റ് ഇൻസൈഡ് ഓഫ് ദിസ് ഇൻ്റഗ്രൽ. സോ ഇൻ്റഗ്രൽ 0 to 2 pi എഫ് സെഡ് ഇൻറ്റു ഡി എസ് minus integral 0 to 2 pi e raised to is into f of e raised to is divided by e raised to is minus z ds is equal to 0. Or I can write minus plus. Okay, so which implies comparing these two integral, I can write integral 0 to 2 pi, okay, e raised to is f of e raised to is divided by e raised to is minus z, okay, minus f of z ds equal to 0. So this our main claim will be integral 0 to 2 pi this integral is equal to 0. Actually, what is this? This was the representation of fz. അല്ലേ? അപ്പോൾ നമുക്ക് പ്രൂവ് ചെയ്യേണ്ടിയിരുന്നത് എഫ് സെഡ് ഈക്വൽ ടു 1/2π ഇൻറ്റു ഇൻറ്റഗ്രൽ 0 to 2 ഇൻറ്റഗ്രൽ ഓവർ ഗാമ എഫ് സെഡ് എഫ് ഡബ്ല്യു ഡിവൈഡഡ് ബൈ ഡബ്ല്യു മൈനസ് സെഡ് ഇൻറ്റു ഡി ഡബ്ല്യു എന്നായിരുന്നു. സോ ടു പ്രൂവ് ദാറ്റ് റെപ്രസെൻറ്റേഷൻ വി റീചേഞ്ച് ദാറ്റ് ഫോർമാറ്റ് ഇൻറ്റു സം ഇൻറ്റഗ്രൽ ഓഫ് ദിസ് തിങ് ഈക്വൽ ടു 0. So we need only prove that this integral value is equal to 0 for proving the representation of fz. Okay? Ready? So to prove this integral is equal to 0, likewise in the example discussed in previous video, we need only prove there is a function psi with the required property of previous proposition. Okay. So I define a function now. Let psi s of t equal to psi st equal to, which is a two variable function. I defined like f of z plus t into e raised to is minus z, e raised to is whole divided by e raised to is minus z minus fz. So I define psi s of t as f of z plus t into e raised to is minus z into e raised to is divided by e raised to is minus z minus f of z. Okay. So when you define psi of st as this, where 0 is less than or equal to t is less than or equal to 1 and 0 is less than or equal to s less than or equal to 2π. Okay. So since f is analytic function and mod z is strictly less than 1, I can say that this function psi is continuously differentiable. Okay, which implies psi of st is analytic or continuously differentiable. Analytic. Okay, then if you define, then let g of t equal to, by that previous theorem, integral 0 to 2π psi st ds is analytic by previous theorem, by previous proposition. Okay, so this will be analytic. So which implies the function g of t is continuous. And what is g of 0? G of 0 equal to integral 0 to 2π psi of, instead of t we have to write 0, s0 ds. So which is equal to integral 0 to 2π. What is psi of s0? T will be 0. So this the whole term will be 0, that is f of z e raised to is divided by e raised to is minus z minus fz ds. Okay, so which is equal to integral 0 to 2π fz e raised to is divided by e raised to is minus z ds minus integral 0 to 2π, okay, fz ds, which is equal to, fz can be taken outside because z is not a variable here, integral 0 to 2π e raised to is divided by e raised to is minus z ds minus fz into integral 0 to 2π ds. So that will be 2π, okay, fz into 2π. So which is equal to, so we have a result that integral 0 to 2π e raised to is divided by e raised to is minus z ds is exactly equal to 2π, which is also proved in the previous video. Please watch it. Therefore this will be fz into 2π minus 2π into fz. So we get the value 0. So we have g as an analytic function and that value of g at the point equal to 0 equal to 0. അപ്പോൾ അതൊരു അനലിറ്റിക് ഫംഗ്ഷൻ ആണ്. അതിൻ്റെ g0 എന്ന് പറയുന്നത് 0 ആണെന്ന് നമുക്കറിയാം. If we prove g is a constant function, then g of 0 and g of 1 will be equal to 0 itself. So by using that idea, we can prove our claim. Okay, so for that I am going to prove g is constant function. In order to prove g is a constant function, we have to find out its derivative. അപ്പോൾ g dash of t എന്താ സംഭവിക്കുക? So by previous theorem we have g dash of t is equal to integral a to b dou psi by dou t ds. which is equal to integral 0 to 2 pi. Here dou psi by dou t. Adenda variya, we have psi equal to, we have psi of st is equal to this function, right? So what is the partial derivative of this right side equation with respect to t? Okay, find out. E raised to is a constant term, therefore e raised to is. T ആണ് അവിടുത്തെ വേരിയബിൾ. സോ e raised to is ഞാൻ അവിടെ നിർത്തി. ഇനി ഇതിൻ്റെ ഡെറിവേറ്റീവ് എഴുതുമ്പോൾ അതിനകത്ത് ടി ഉള്ളത് കൊണ്ട് ദാറ്റ് വിൽ ബി എഫ് ഡാഷ് ഓഫ് സെറ്റ് പ്ലസ് ടി ഇൻറ്റു ഇ റേസ് ടു ഐ എസ് മൈനസ് സെറ്റ്, റൈറ്റ്, ഇൻറ്റു ദ കോഎഫിഷ്യൻറ്റ് ഓഫ് ടി അല്ലേ, ഇതിൻ്റെ ഡെറിവേറ്റീവ് കൊണ്ട് മൾട്ടിപ്ലൈ ചെയ്യണം. സോ ദാറ്റ് വിൽ ബി സെറ്റ് ഡെറിവേറ്റീവ് സെറ്റ് ഈസ് 0 ആൻഡ് ഡെറിവേറ്റീവ് ഓഫ് ദിസ് ടേം വിൽ ബി ഇ റേസ് ടു ഐ എസ് മൈനസ് e raised to is minus z, and there is a constant term again in the denominator, that is e raised to is minus z. Okay, minus, what is the derivative of fz? T is not a variable here, therefore that derivative will become 0 ds. So this thing will be cancelled. We get integral 0 to 2 pi, okay, e raised to is, okay, f dash of z plus t e raised to is minus z ds. So this is our g dash of t. Okay, now let phi of s is equal to, ഇത് തന്നെയാണ് നമ്മൾ ആ പ്രോബ്ലത്തിൽ സോൾവ് ചെയ്യുന്നത്. ഈ പ്രോബ്ലം ഈക്വൽ ടു 2 പൈ എന്ന് സോൾവ് ചെയ്യാൻ നമ്മൾ ഏത് മെത്തഡാണോ ഫോളോ ചെയ്ത്, ദ സെയിം മെത്തേഡ് ഈസ് ഫോളോയിങ് ഹിയർ. ദർഫോർ phi of s is equal to, I define whatever, ഏത് ഫംഗ്ഷൻ്റെ ഡെറിവേറ്റീവ് എടുത്താലാണോ ഇത് കിട്ടുക, അങ്ങനെ ഒരു ഫംഗ്ഷനാണ് ഞാൻ phi of s ആയിട്ട് ചൂസ് ചെയ്യേണ്ടത്. ദാറ്റ് മീൻസ് ദ പ്രിമിറ്റീവ് ഓഫ് ദിസ് ഫംഗ്ഷൻ. ഓക്കെ, സോ ദാറ്റ് ഈസ് മൈനസ് ഐ ഇൻറ്റു ടി raised to minus 1 f of z plus t into e raised to is minus z. Okay, then what will be phi dash of s? Phi dash of s is equal to, with respect to s ആണ് വേരിയബിൾ എടുക്കുന്നത്, so minus I t inverse or t raised to minus 1 into the derivative with respect to s ആണ്. so ഇതിനകത്തില്ലേ, so this function contains the variable s, therefore its derivative is f dash z plus t e raised to is minus z into derivative of the terms in the bracket, therefore derivative of z is 0, okay, plus derivative of this thing will be exist, so t into e raised to is in the derivative vary, so that is I e raised to is. So that which is equal to I into I is I square is minus 1 minus is plus positive 1, and t raised to minus 1 into t, so that will be t raised to 0, so that will be become 1. Okay, so the whole term will be, so which thing is equal to this e raised to is into f dash z plus t e raised to is minus z. So you can see that this phi dash of s is nothing but this term in the integral, right? Therefore g dash of t can be written integral 0 to 2 pi. Instead of this term I can write phi dash of s ds. So by again fundamental theorem of calculus, integral derivative will become cancelled, so this thing will be phi of 2 pi minus phi of 0. Okay, phi of 2 pi minus phi of 0. So what is phi of 2 pi? Phi of 2 pi means we are giving the value 2 pi for s, so that will be minus I t raised to minus 1 f of z plus t into e raised to is. When s is equal to 2 pi, e raised to I 2 pi, that will be 1, so 1 minus z. Minus what is phi of 0? S is equal to 0, that is again minus of minus will be plus I t raised to minus 1 f of z plus t into e raised to 0 is again 1 minus z. So both the terms are same in different sign, therefore that is equal to 0. So which implies g is constant. So which implies g of 0 equal to g of 1, and we already have g of 0 equal to 0, right? Here the g of 0 equal to 0, we proved that. So 0 equal to g of 1. So what is g of 1? We have g of t equal to integral 0 to 2 pi psi st ds. Therefore what is g of 1? We have g of 1 equal to 0 now. What is g of 1? Integral 0 to 2 pi psi s1 equal to ds is equal to 0. What is psi s1? That is integral 0 to 2 pi. We have psi of st is equal to this function, right? Therefore what is psi of s1? Psi of s1 will be f of, okay, z plus t equal to 1. So instead of t, it is 1. So that will be e raised to is minus z. Okay, into e raised to is divided by e raised to is minus z minus fz. This is psi s1. ds is equal to 0. So which implies integral 0 to 2 pi. This z minus z will become cancelled. Okay, that is f of e raised to is into e raised to is divided by e raised to is minus z minus fz is ds is equal to 0. So this was our claim to prove fz has the required representation. So our claim is true. Our claim is true. So which implies fz can be written as 1 by 2 pi I into integral over gamma fw divided by w minus z dz for mod z less than 1. Since we have by our choice a equal to 0 and r equal to 1. So this will be true for any a and any radius in that region G. Therefore fz can be written 1 by 2 pi I integral over gamma fw divided by w minus z dw will be true for mod z less than r. So that's about this theorem.